Hello everyone, today let us discuss about PN junction diode and forward bias and reverse bias of PN junction diode. Very clearly you can see here this is the P type and this is the N type and this is the depletion layer which we talked in our previous video, and this is the symbol of PN junction diode. This triangular shape indicates the P type and one line, that is bar, indicates the N type of the PN junction diode. Now let's go into the discussion without wasting much time. Yes, what is forward bias? You can see here when P is connected to the positive terminal of the battery and N is connected to the negative terminal of the battery, we call it as the forward bias. When an external voltage V is applied across a semiconductor diode such that P side is connected to the positive terminal of the battery and N side to the negative terminal, it is said to be forward biased. The applied voltage V is opposite to the built-in potential VO. So we have seen in our previous video, here there is a potential barrier. The direction of the potential barrier is from positive to negative. Here is positive and here is negative. But here applied voltage, here is positive, here is negative. So applied voltage is in opposite direction to the built-in potential VO. So therefore, the applied voltage V is opposite to the built-in potential. As a result, the depletion layer width decreases. Previously we have seen, even in our previous picture, here you can see this is the depletion region, which they have shown here 2 rows of positive ions and 2 rows of negative ions. But when you come here, they have shown only 1 row of positive ions and 1 row of negative ions. That is, the width of the depletion layer is reduced. The effective barrier height under forward bias is V minus VO. So you can see here V minus VO in the forward bias, that barrier potential decreases. I will explain it also here. Now you can see here, if the applied voltage is small, the barrier potential will be reduced only slightly below the equilibrium value. So the current will be small. If we increase the applied voltage, the barrier height will be reduced and more number of carriers will have the required energy, thus the current increases. So let's go back and see here. You can see 1, 2, 3 here. 1 is without battery. Second is low battery voltage. Barrier height is reduced only a little here, that is number 2. Number 3, high battery voltage. So when the battery voltage is increased, barrier potential, that is decreased to the level 3. So this is how the barrier potential decreases with the increase in the forward voltage. Okay, so due to the applied voltage, so when we apply the voltage, electrons from N side cross the depletion region and reach P side. Okay, due to the applied voltage, electrons from N side cross the depletion region and reach P side. Similarly, holes from P side cross the junction and reach the N side. This we also talked in our previous video. This process under forward bias is known as minority carrier injection. So this is the word which you have to know. This is called as minority carrier injection. Now, the magnitude of current in the forward bias is the order of milliamps. This is another point to be noted. Whereas in reverse bias it will be microamps. Now let's go for reverse bias. So here you can clearly see this is our plus and minus. Okay. Now here you have, this is plus and minus, that is the direction of the barrier potential, and applied voltage plus and minus both are in the same direction. Therefore, the width of the depletion layer increases, even the height of the barrier potential is also increased. Okay, now let's see, when an external voltage V is applied across the diode such that N side is positive and P side is negative, it is said to be reverse biased. N side is positive, P is negative, then it is called as reverse biased. The direction of the applied voltage is same as the direction of the barrier potential. As already I have shown you, both are in same direction, barrier potential and applied voltage, plus plus and minus minus. As a result, the barrier height increases and the depletion region widens due to change in electric field. So previously I have shown you in the reverse bias. Now in the forward bias I have shown you here only one row of positive ions, one row of negative ions. In general it is two rows of positive ions, two rows of negative ions, but when you come to forward they have shown that is width of the depletion layer decreased. Now when you come to reverse bias, you can see here very clearly the width of the depletion layer increased. They have shown three rows of positive ions and three rows of negative ions. Now the direction of the applied voltage is same as the direction of the barrier potential. As a result, the barrier height increases and the depletion region widens due to change in electric field. The effective barrier height under reverse bias is V plus VO. Now you can see here it is increased from 1 to 2. Now earlier it was VO, now it is increased to 2 second level. The drift current is of the order of microamps in reverse bias. This is very low because it is due to the motion of carriers from their minority side to their majority side across the junction. Now, the current under reverse bias is essentially voltage independent up to a critical reverse bias voltage known as breakdown voltage. As you are increasing the reverse voltage, at one particular value, current suddenly increases. That value is called as breakdown voltage. It is under the reverse bias conditions. When V is equal to VBR, that is the applied voltage is equal to the breakdown voltage, the diode reverse current increases sharply. So this is the importance of the term breakdown voltage. So at the breakdown voltage, current increases sharply. Even a slight increase in the bias voltage causes a large change in the current. If the reverse current is not limited by an external circuit below the rated value, the PN junction will get destroyed. If you don't control the reverse voltage, the PN junction diode will be destroyed permanently. Okay, this is all about PN junction reverse bias. So this is the reverse bias. Once again I'm showing you the pictures. This is the picture of forward bias minority carrier injection, which I have shown you earlier. I have explained you earlier, that is the term minority carrier injection. So this is the forward bias and this is in general the picture of PN junction diode. Now this is the forward bias. Now this is minority carrier injection, which I told you here. So this is minority carrier injection, the injection of electrons from N side to P side, injection of holes from P side to N side, already we talked. And this is the reverse bias and the barrier potential, and this is the finally breakdown voltage, which is the most important term for the reverse bias. Okay, thank you for watching this video, and let us meet with another video in the next video, and God bless you all and grant you all great success in the exams.